In this lesson, we're going to investigate Elastic Load Balancers, Amazon's load balancing solution. Let's first look at load balancers in general. Their main purpose in life is to send traffic to many backend servers. They attempt to evenly distribute this load, usually using one of several different algorithms. Here we have a load balancer with several EC2 instances behind it. Traffic coming into that load balancer should be evenly distributed to each of the machines in the backend. Load balancers allow your services to be what we call elastic. They also allow for horizontal scale, which we'll talk about in a bit. This basically allows you to grow and shrink on demand. If we look at horizontal scale, here we have the Elastic Load Balancer at the top, with two EC2 instances behind it, which is great for a single user. But when many users come and hit the site, we can simply grow out more EC2 instances. If you compare that with vertical scale, here we have a single EC2 instance. When users hit that instance, we can add more resources to that single instance, but you eventually run out of RAM, CPU, and so forth in a single instance. Horizontal scaling in the cloud gives us near infinite scale. We can keep adding more and more instances behind that load balancer. It also gives us cost savings. During downtimes, we can use fewer servers. It also allows for high availability and scaling by tier. Let's look at scaling by tier. Here we have an Elastic Load Balancer with two availability zones behind it. We have a web tier, which is being balanced to a software load balancer, and then an application tier behind that. We could scale our web tier independently of our app tier. It also allows for high availability. If, for instance, we lose one of our EC2 instances, we still have three running. And in fact, we can lose an entire availability zone and still have our application running in the other. Amazon's load balancer is called an Elastic Load Balancer, or ELB. It's very simple, it's very scalable, very easy to use, and it integrates tightly with the auto-scaling groups. It auto-scales by adding more IPs behind a DNS endpoint. It can terminate SSL for secure web connections, and it can encrypt SSL to back-end machines. It supports X-Forward4 so that user IPs can be passed through to the web servers, and it has deep integration with autoscaling and CloudWatch, which are also known as the Triangle services. Here we have autoscaling and CloudWatch, with instances in the autoscaling group firing off CloudWatch alarms, which tell the Elastic Load Balancer to add more instances to the autoscaling group. The ELB does come with some pretty strict limitations. It has very simple algorithms. You can either choose from sticky sessions, where users talk to only a single EC2 instance, or you can do round robin among the instances, which is preferred. You want to try to avoid state or sticky sessions in your architectures. It also cannot block external traffic, which makes it a poor choice for balancing in the web to app tier. This wouldn't be an issue in your VPC because your VPC can be locked down to only specific traffic. You can also roll your own load balancer at any time, with HAProxy and Nginx being probably the most popular choices. Let's take a moment to look at the auto-scaling CloudWatch integration. ELB can detect unhealthy instances. Unhealthy is determined by either a TCP or HTTP check. You could put up a web page that the ELB checks to see if an instance is up, and then automatically remove the instances from scaling if it detects that they're unhealthy. CloudWatch can add more instances behind the ELB, either based on ELB metrics such as request count, latency, and more, or based on instance metrics themselves, such as CPU, I/O, or custom metrics. Logically, you want to always think of an ELB as this, a single ELB balancing across many EC2 instances. But what actually happens is it does DNS round robin across many ELBs in each independent availability zone. If we look at the implications of this, remember that the load is balanced first by the AZ, and then across instances in the AZ. The ELB cost is always static, regardless of how many IPs or ELBs are actually used, but ELB scaling is always reactive. It's always going to be a bit behind the curve. If you know, however, that you're going to have, let's say, a big email drop on a certain day at a certain time, you can call Amazon up and ask them to pre-warm the ELBs for the amount of traffic you expect to receive. Always think of ELBs in the logical sense of a single ELB balancing across many EC2 instances. The ELBs are supported through the web GUI, and you can easily spin them up there. They're very cost-effective, typically 5 to 10 times cheaper than roll your own with EC2. They're very easy to use, but they may not meet all needs. By now you should have a very good picture of what ELBs are and how they function inside of Amazon's architecture.